Hi, this is Tag again, and recently I bought a bunch of broken GPUs. So I'm going to take you along the journey of trying to fix them, and let's start with a bit of an overview of what I got. Now these three are not the only ones, they're just the first ones I put on the desk here. Now I'm going to take you along and take you through the whole diagnosis process and hopefully manage to fix some of them. Now this here is a Geforce4 Ti 4600, so one of the higher end Geforce 4 cards. Now this one here is in a really sorry shape, as you can see already. There we are. Now no fan, and this here should be V-core or VGPU. It's missing a choke. So obviously this card is never gonna work. But unfortunately, the previous owner here also did some very poor solder jobs on here. See these MLCCs here. There are some flux around here. There is a bunch of components missing. So let's start off with this one and go through the steps. Now first, I'm going to check for shorts on the input rail. So this here is the 5V rail, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 part in is the 3.3V rail. So all fine on those two. On the back we have on the first pin the 12V rail. Also all fine. Okay, let's check the output of our VRMs. Now this is VGPU, I think might be VMM. No, this is definitely VGPU, 16 ohms. Let's get a good card in here for a reference. This is a fully working one. And 17 ohms, so our GPU rail is fine. Let's move up. This one is VMM. Okay, so this is the first problem. We have a short on VMM and VDT of some sort, or PEX, or however. I really don't have a datasheet for any Geforce 4 series, so I don't know what the rails exactly do. But this one is definitely, come on. Huh. Did I charge the capacitors all the way up? Well, it definitely also is fine. So, next step, before I take a look at the back, we got positive side for, I think, 5V or something here. Let's go to positive of all our output rails. Just in case it's split. No, it's not. Looks good, so we don't have a high side short on any of these. Now I think that our VMM short comes from this poor soldering job at these two MLCCs, so let's just quickly remove them. There we go. Go away. And if that fixed our problem, then first step is done. You can't see. Great. Yep, that's the problem. So short is gone. Now there is a lot of other stuff on this card. So it's going to be a long one. Now, I wish I had a microscope so I could see better, but I don't. So let's start. Down here we are missing two capacitors and a resistor. Usually capacitors are not that critical, but resistors usually are. So we have our 106 here, and if I read this right, this should be 20 kilo ohms. So let's get this in here. Good card in here. Check this. Oh, 200 kilo ohms. See that? Me not being able to read resistor codes correctly. So let's take a 200 kilo ohm resistor and put it on here. And a lot of this card is going to be just putting resistors in places. 200 kilo ohms. Great, that's like 3 of them. And just double check, because last time, yep, 200. Because last time I repaired something, I wondered why it wasn't working, and it turned out that the resistors in my little resistor booklet were in the wrong pouches, so I put on a resistor that was half the value it should have been. So let's get a resistor. Great, it's really sticky. Get off there. This is really not an ideal position to solder in, or the right soldering iron. We're going to get that one on there, and hopefully in a way that you can see it as well. And there we are. Alright, nope, definitely not. Yep, that's the pads, okay. Because to make it that you can see it, basically I don't see anything, I just see reflections. Okay, now we got a 200 kilo ohm resistor. And that's only the start of, yep, that's fine. Now I think we have another problem right here. This one here is loose. I'm just going to sort of put it back up here. Okay. That's not gonna work, because we are missing a leg over here. So what kind of thing are you? You're something with the, either AGP detection or this valve. Let's see. K502. No, this is something else. Let's see if I can see through the camera what it says on there. Probably not. No, not a chance. Okay. Okay, so this might be a bit of a problem. We do not know what this thing does. So I can't exactly replace it. Let's remove it. Okay. I'm going to try to solder to the little leftover of a leg we still got. Okay, where did that little thing go? Okay, there we are. This just might be possible. Put it on there first. Not a view. Sorry if the image kind of sucks from time to time, because sometimes I have to see what I'm soldering, unfortunately. Okay. Really should put the small iron tip on here instead of the one I use for wicking and e-power and stuff. I feel like we got it. No. The real challenge. Oh, never mind. Looks like we got it. Okay. Now just really carefully remove the bridges. Yeah, it's far in as it goes, unfortunately. Trust me, I'm seeing even less than you do. Yeah, it went away again. Great. Remove the bridge and retry. And this worked. I think. Yep, that worked. Okay, so let's move on. The back side, now we have two caps here. We also have a bad soldering job from previous owner over here. So let's see. Can at least make it a bit nicer. Nah. This lead-free stuff that was on here is complete garbage. Or I suspect it's lead-free. It actually melts too easy for lead-free, so I'm not sure what it is. It's definitely crap solder. Okay, so we get this it does. Okay. I think that looks way better. Just quickly check that we didn't add a short on the memory rail again. We did not. So for the bottom ones, I'm just going to steal some memory rail filtering capacitors from some sort of card that has GDDR1. Just need some of the right size. Now, those are filtering capacitors, so exact value of them is not really that important. Just needs to be roughly the right one and rated for enough voltage. I could also just use new like 10 microfarads, that's way too much, but it would run and it would probably even clock better. But I'm not gonna waste new capacitors on a card that is probably dead. And I'm not certain if I can actually fix it, because it looked pretty bad. Okay, one capacitor, two capacitors. Great. Put these on here. 2. Good enough. All fine. So let's move on to more of the resistors. We are missing one here, and one here. Now the first two are, I'm not going to show you again the reference card, it's 10 kilo ohms each, so to have two 10 kilo ohms here. And the last one is what kind of worries me the most about this card, to be quite honest. Because it was a feedback resistor, I think, and depending on which side it was, it might have killed our GPU. So I said these were 10 kilo ohms, so let's get some 10 kilo ohms. Oh, I'm almost running out of 10 kilo ohms. Two 10 kilo ohm resistors. Don't want to get a stage where I have to start salvaging resistors, tiny little SMD resistors of cards. That's a level of cheap even I'm not going down to. Let's get a couple of these here. Which pads was it? The ones facing the side, okay. Cool. Okay. Okay. Those are the right positions, yes. Lock them up. Add some solder. Okay. So the last one is this one here. This is some sort of divider. The back one measures, yeah, this is, let's check something. I think the bottom one was V-core, right? Cool. So this is V-core, and let's see if either one of those sides goes to our V-core. Cool. This is probably the ground side. So the top one is definitely a ground. Yes. Okay, so this is the ground side, and this is 160, so this is memory. Not good news, I think. Because the one that is missing is going towards VMAN. Which probably means that our VRM, depending on how it is set up, pushed either 3.3 or 5 volts into MEM. Now if it was 3.3, we are fine probably. But if it was 5, I don't think we have a good memory, a good IMC or good memory chips anymore. Okay, so let's clean that up. Now on this card the values of this divider are slightly different, but the front one is ever so slightly lower, and the back one on this here is 750 ohms, I think. Yep, so probably going to use something like 700 here. Or 680, I guess, is the next size I have. Okay, there's one. I have no idea where the resistor went. I put it on the GPU. On there. Yeah. Okay, now we should have about half the, can't see anything in, half the resistance. Yep, that's good. So let me check if I can find any other issues here. Nope, looks good. So let's, this is the only 4.7 microhenry inductor I could find. So I'm going to be using that, I guess. Is there a piece of trace ripped off here? No, it's fine. Okay. There is also a loose capacitor here. We can just put it back. So a lot of those are going to get swapped anyways if I actually manage to revive this card. Yeah, and you can't see anything yet, great. We need to set up this camera differently for the next card. I'm like working at the end of the table. It's not really working for me. Can't see half of the time. Let's put this on here. Come on. Back here. There you go. Push it a bit further in here. Okay. This isn't great. Not at all. Definitely not done proper. And I think if this thing works at all, this works, I'm going to replace that inductor with a higher amperage rated 2.2 microhenry, and then slap some more caps on the output and hope that that works as well. So what else do we have? Okay, we have a capacitor missing here. So I think these silicon image chips are only used for our DVI port. So worst case, our bottom DVI port doesn't work, so that's fine. I'm not gonna fix that. And then there is also two capacitors back here. And I'm just going to try without those. Don't think they are necessary. And I don't have a donor card that has the exact same layout where I could find out what value they would be. Oh, actually, now that I see it, there is a resistor right here, another one, and one of them looks like it's knocked off, so let's check. It's 70 kilo ohms. Okay, that's also 70 kilo ohms. And this one is 100 kilo ohms. This one is also 100 kilo ohms. So if this is a divider of some sort, then 70/70 should be fine. Okay, so somehow this stopped recording. I just said I'm going to replace the correct one, so move it. And let's recheck our resistances. Now we have 50 kilo ohms. How can removing a resistor make our resistance lower? Doesn't make any sense at all. Did I short something here? Okay, if there was any. Okay, so we're at 70 kilo ohms again. We're at 70 kilo ohms in the front as well. That means those resistors are not the main part we're using here. So I guess my only way of determining what kind of value we have here is removing the one on the other one and measuring it out of circuit. Let's quickly do that. So this is 100 ohm or 110 ohm resistor. So that helps. I'm not sure how I can measure 110 ohms out of circuit and in circuit it measures more. It doesn't really make sense to me. Alright, wait a second. No, this totally makes sense to me. It just means our second one on the other card is also bad. And because the values were relatively similar, but kilo ohms versus ohms, I just thought it was the same. Yeah, okay. So this means our front one is also bad. Let's see if it's just that soldering job. We do both sides. One is also cracked inside. Okay. Now let's check. Yeah, that one is also dead. Cool. Let's remove it. Let's just put some 110 or something ohm resistors on here. Okay, so those two are on there. Now we should have basically the same values on the other card. Yep, 110. 110. Okay. Now I think this is the last thing I see besides obviously the capacitors. I think I'm reasonably confident now that I can try to post this card. Actually, never mind. This little transistor down here is knocked off to the side. But I think I can just resolder the legs on that and it should be fine. Moving all over the place, great. The top one isn't really solid either. Not very nice, but certainly functional. Yep. Get all output inductors here, so we're actually going to get an output if the card puts out anything. Yeah, I think I'm going to test post this, and well, I give this about a 50% chance of displaying anything at all, and a 0% chance of not giving us artifacts, so let's see. Okay, so moment of truth. Turn it on. 2E, D5, 2A, and we have a picture. Now, not a very good picture, but we have a picture. Go into BIOS, you stupid thing. Yes, there we are. Now I have my little reference for which memory chip is like which artifact pattern. I'm going to do a detailed like guide on that someday anyways. But I can already tell that we probably were right when I said that our memory got sent 5 volts or something like that. Because it looks like we got errors on pretty much every single memory chip. Okay, so yeah, I'm going to continue the diagnosis on this. Okay, so quick update on this one. Now I unfortunately can't show you, but basically when I press on the memory chips, I can get most of the artifacts to disappear. That makes me think it's actually you might have gotten really lucky here, and it might just be some bad balls on the memory chips, because this card was probably thrown around a lot at the scrapyard or something similar. So next step for this card is a nice long bath in paint thinner to get off these memory heatsinks, and then we're probably going to go one by one and reball all of these memory chips. That's going to be fun. A couple days later, and well, I made some progress. Let me show you how the artifacts look like now, and then going to take you to the bench later. And well, I'm not entirely hopeful, as you can see, but we can read the screen way better than before. So I fixed a couple of the memory chips. Sorry for the cut right there, I kind of pushed the wrong button. So yeah, that's what BIOS looks like now. But you can see these stripes here. I just couldn't get rid of them. That's memory chip 5 or 6. And well, let me take you to the bench and show you what I did so far and what I'm planning to do now in a sort of last ditch effort. There we are. Now, as you can see, I got the heatsinks off with some difficulty, but not too much. Anyways, basically I reflowed this chip and this chip, and that fixed a whole bunch of the artifacts. I just reflowed them, no reballing or anything. But this here was another story. As you can see, there's both a Hynix chip on here and there is some green stuff around the corner. Now, basically what had happened here is that some impact to the card ripped off this corner pad from underneath the chip, so on the PCB, not on the memory chip itself. And I sort of had to fix that. Just made a replacement pad out of a like AGP finger trace from a different GPU and glued it into place with UV solder mask. Now I'm reasonably confident that I have connection on all the balls here. Already had with the Samsung chip, but I was thinking that maybe the shock had internal damage the chip or something. So I swapped it over to this Hynix here, but I'm getting the same exact artifacts. I also tried a Samsung from the back, here where there's also a Hynix now. So I swapped the Samsung on the back that I was more confident it might work, onto the front and put a Hynix on the back, and it changed absolutely zero things with the artifact pattern. So it's exactly the same. No matter if that's both Hynix, one Samsung, one Hynix. Only thing you noticed on the first couple tries, I didn't really get the replacement pad perfect, so there was a difference in artifact pattern if this corner ball doesn't make contact. I think it's the data line. So that's what you'd expect if you have a data line not connected. So really all that is left with this GPU would be to reflow the core. Now I can just reflow it. I can't reball it because I don't have a stencil for it, and I'm not nearly good enough to reball a core without a stencil and without a microscope. I know there are some crazy people that can do that, but I can't. So I'm just probably going to try that. This is not a flip chip core, so the usual like heat cycling or something like that that's sometimes used as a temporary fix for like I think it got big with the original Xbox or Xbox 360, can't remember. It's not gonna be a temporary fix here. If reballing fixes a core with this packaging type, then it was actually the balls being bad, and you actually have to heat it up to the point where your solder melts, which on this card is luckily leaded solder, so it should be safe-ish for the core. So that's the last thing I'm going to do, and yeah, after that I'm going to share an update. I'm not really that confident, honestly. I think this card has been thrown around and abused a bit too much to be savable. On a positive note, I managed to fix a couple other cards from the lot. On some of them I'm going to do a video. Some of them I fixed without filming, just didn't really have the motivation to film. So I might be doing a quick overview video basically of all the cards that I fixed after I'm done with the more detailed ones. Anyways, yeah, I will be back with this one once I got the reflow done. I can't really film it because basically I would have the hot air station like this and you wouldn't see anything. So yeah, until later. So it's just about 2 months later and I finally found time again to do some YouTube stuff. And this is the 4600 that we left off with about 2 memory channels artifacting last time. And unfortunately, I do not have any footage of me actually fixing the issues. Basically, I needed the card for Team Cup. Well, not I needed it because I had another card to bench, but basically I wanted to fix this card so I could give it to a teammate so he could run it for Team Cup. And so the fixing was done off camera and basically just for getting a score. But yes, the card works. I'm obviously going to show you test post later. And I'm also going to show you the scores because he actually managed to beat the Geforce4 record for 3D01 on this thing. So it works pretty well. Now, what changed since last time? Basically, I took off the core and I did reball it. He had a stencil for it, so that's how we did it. There we go. Now, you're not gonna see anything here. But yeah, core is reballed. I noticed that if you pulled up on one of the corners, it would sort of come loose, and that happened in 3 corners here. So yeah, it definitely had some rip balls. It actually also has some rip pads under the core, but most of them were non-populated, and the couple ones that weren't non-populated were all just V-core and ground pads. You don't really need all of those, so there's no pad fixes under the core. Other thing I did was I replaced all the memory chips with Hynix. So we have 8 Hynix chips on here. They're kind of funny, they're like from 5 or 6 different production dates. So if anybody ever just looked at the card and wanted to check the memory chips, they would be kind of confused why they're all sort of different, I think. But yeah, let's put the cooler back and post this thing. Also, I fixed the fan. Now it has a bit noisy fan, but at least a fan that works. Oh yeah, V-core inductor, right. I removed the sketchy 4.7 microhenry inductor here and replaced it with a 1.5. Now the 4800s have 1.5s from factory, so I was pretty sure it would be fine, and it definitely is because the card performs pretty damn well. So yeah, let's put this on the bench and show you what the end of this journey is. Okay, so let's go. Now the fan is rattly if you spin it by hand, but if it's actually running it's fine, which is pretty nice. And as you can see, this looks pretty clean. And BIOS looks clean too. So yeah, it took me quite a lot of time to get this thing fixed, but I'm pretty sure that the Geforce 4 stuff is very, very resilient by now, because I heated it up way too many times for it to still be alive, to be honest. Like, as you have already seen, I reflowed the memory chips, I reflowed the core, like half sketchy reflow with the hot air. I mean, not that sketchy, it does have proper temp control and everything. But yeah, it still runs just fine, and I didn't degrade anything. I'm pretty sure of that, because it's one of the highest core and highest memory frequencies ever passed on a Geforce 4 4600 Ti. Now, to be fair, most of the scores before that were on chilled water or stuff like that, and he was running LN2, so a bit unfair, but still, the card is still very, very well working, and I'm honestly amazed, because I'm still pretty sure that the memory got 5 volts, and yeah, it obviously got thrown around a bunch. So yeah, that's it for this 4600. It's back with the living.